So how does AES encryption work? Well, AES encryption is a symmetric block cipher, and by symmetric we mean that both parties have the same key, and a block cipher means that we're breaking up the plaintext into multiple chunks of blocks where each block is operated on individually. And so that's to make it more secure. And then we're going to have a key as well. And so our first step is, so we have our plain text here. It's a message that you'd want to encrypt. And then we break that into 4x4 bytes. And we're going to call that the state. And then, as I mentioned, we have a key. And our key is also a 4x4 array of bytes. So that's to ensure that we can apply the key to every single byte of our state and make sure that each byte is encrypted. So what's our next step then? Now that we've got our state and we've got our key, we have to put the key, our original key, into a key scheduling algorithm. And what this does is it generates 9 round keys. And why do we need 9 round keys? Well, our state goes through 10 rounds of transformations, and those transformations are the reason why AES encryption is regarded to be so secure. So what are the steps then? So we have our initial state, so that's just our plain text, and then we first want to start by adding our original key onto this state. And this is a simple XOR. So we're XORing every single byte of our state with every single byte of our key. And that becomes our new state. And then we start to transform it. So what are our transformations? Well, our first transformation is going to be subbytes. And what is subbytes? Well, we have each byte of the state, and we have what's called a substitution box. And that substitution box tells us what we want to substitute each byte of the state with. So let's say maybe this byte's going to be A, this byte's going to be D, and then after subbytes, we substitute it with something else, and then maybe that becomes E, and this becomes F. Of course, it's not going to be as that simple. Like each byte is not going to be an alphabetical. It's not going to be It's not going to be a letter. But this is just for demonstration purposes. And then after subbytes, what do? We then shift rows. So these two steps are what we call confusion. And it's one of the concepts that makes some algorithms much more secure, such as AES encryption much more secure than others. And what is shift rows? Well, we have each row of our state over here, this row, this row, this row, this row, and we simply shift each row to the left by first row gets shifted by 0, second row gets shifted by 1, by 2, and then by 3. So for example, we had a bit here, this doesn't get shifted. If you had B here, this gets shifted by 1. And then if you had like C here, this gets shifted by 3, and this goes over here. And if we had like a byte here, say that's E, this then gets shifted to, this goes around like a circle over here. So that's after we've done our shift rows. And then number 3, our next step of our transformation is then mixed columns. And that's simply where we multiply each column of our state by a fixed matrix, and this is the same matrix that's used in every implementation. And then that's for our diffusion, which is yet another concept that we use to make sure that it stays secure. And then what's our last step? Well, remember how we generated those 9 round keys? This is where they come in. So then we just have to add the next round key. And yeah, so that's each round of the transformation, except for the last step. So the last step, we actually don't do mixed columns because it doesn't add anything to the security of AES encryption algorithmically. So then so in our last round, we do sub bytes, shift rows, and then we add our last round key. And that's how we generate our ciphertext.